So we are talking about networking. Okay, so before I get into networking, as in the technical computer networking part of the term or understanding, let's talk about networking as a word, right? So if you look up what is networking, right, you might see multiple definitions, but in general, networking is really the communication amount multiple objects, right? And those objects can be people, those objects can be animals, right? In our case, we are talking about machines, right? Not necessarily servers, but we are talking about machines as a whole, right? Your phone, even at home, your fridge, if you have a smart fridge, your TV, talking to your routers, and or just being part of the same network, right? Or when we meet with other people at a bar or restaurant, right? We call that networking, right? And usually a network is usually a group of objects, right? Whether it's people or machines that are communicating, or let's just say that are part of the same, well, I want to say same network, but that won't make sense. But let's just say they have the same goal, or at least that should be the case. And when it comes to machines, the term communication becomes very, very interesting. And actually, the more you learn about computers, I don't know how it's gonna sound a bit weird, but the more you learn about computers, the more you learn about people, right? But anyway, let me just show it. So think of a server, right? Again, this could be a regular computer, to be honest. Um, by computer, I mean this could be your personal computer, like your laptop or whatever. But just think of a machine, a server, a computer, just like a house. Okay. So forgive me if my drawings aren't perfect, right? So this is a house, right? And just like any normal home, you have points of entrances, right? So the main door, right? And then you might have windows, okay? Might have windows here, and then you know you might have a back door or some sort of back door, right? Or side door, however your house is made, okay? All right. So this is a regular house, right? So a machine or server is just like a house. What does that mean? In the aspect of networking, there's no network if there's no communication, right? And in IT term or computer term, communication is really translated to what we call traffic. Okay, so when I'm talking to you and you're talking back to me, we're exchanging informations, right? And the IT world, exchanging informations or that bit of information, we use terms like data. Okay, that's pretty much what information data means, right? It's a piece of information. All right. So now speaking specifically about network, just imagine these doors, right? These doors have numbers, okay? So just like you have the front door, you usually just call it the front door, right? If I say, where's your window? You can say, it's the window to the left, right? Upstairs to the left, right? So when it comes to a server, the different entrances or ways to have traffic coming in and out, right? We call them ports, right? Those doors and those ports, remember that? Very, very important term. Okay, ports. Okay, that's an R, by the way. A port, two ports, right? So, okay. So, for example, let's say this side door here, we call this side door 10. Okay, so instead of saying side door, we give it a name called 10. Okay, and this front door, we give it a name, not a name, a number 22. Okay, and this window here up to the right, at least when I'm looking at it right here, we give it 4, 4. 3. Okay, and this window right here, we give it 80. Okay, so this is a computer, this is a machine, right? And like I said, we give our entrances, right, ways to have a communication traffic, right? We give them numbers and we call them ports. Okay, and just like your house, you have a form of security, right? Security meanings you have specific rules about who comes in, who comes out, and also you have rules about which door you should use. For example, in a normal home, one of your rules should definitely be nobody should go through the windows, right? In a normal home. Or you can say you can go through the windows. It's your house. Nobody's gonna, okay? It's not against the law. It's your house. If you want people, if you allow people, or if you want to go through the windows yourself, you can do it, right? So that those sets of rules, right, when it comes to a computer, it's control or it's set up by something that we call the firewall, right? So fire, and I'm really trying my best here to type. I mean, I'm not typing. I'm pretty much writing here. All right. So, like I was saying, we call this the firewall, and like I said, the firewall is just the, if I can call it the service or the tool, or the maybe just a term, but really a service, especially when you get to the cloud. When you learn about what the cloud is, you understand why I call it a service. Because when it comes to the cloud, especially with AWS, there's something called security groups, and that's pretty much where you set your firewall rules. And like I said, in this firewall, all your rules about your traffic set. So let me go ahead and type that. Actually, it's much easier to type than writing the words, drawing the words like that. Firewalls. Okay, perfect. All right, so you have your firewalls. So let's say, for example, you don't want anyone to go through the door 10, right? Which is your side door, right? In your firewall, you can set up a rule that says no traffic going through door 10, or the back door in this case, all right? And also your firewall, you can specify which traffic you want to avoid, right? So for example, you can say this process, or this IP address, right? Or this process coming from this range of IP addresses, right, can go through 10, or you can be very specific, basically, right? And also, if you heard what I just said there, I used a word called IP address. And to kind of explain what an IP address is, if you don't already know, again, this is a house, and this is why using the house term, I guess, terminology or explanation, it's such a great way to explain networking or servers as a whole, really, especially I guess in the realm of networking, because it's really what it is. And what I'm trying to say here is, just like a house, you have a way to locate the house, right? So if you live in California, if you live in I don't know, Calabasas, right? If you live somewhere in Calabasas, let's say your address is I don't know, let's say your address is 1450 Forest Hill. I actually don't know if this is a real address, but okay. Forest Hill, Calabasas. Is that how you spell Calabasas? I don't think so, but it doesn't matter. And so Calabasas here will be your city. I'm not from California, guys. I'm from Texas, so I'm not even sure if Calabasas is really a city, or if it's just the hills. But anyway, in this case, let's just say Calabasas is your city, right? And then your state will be California, right? And then your zip code, I don't know, this is 92033. It doesn't matter, whatever, right? So this is the way we can locate your house, right? And so if I have to come to your house, if I have to deliver a message to your house, right? Whether it's an actual package, whether it's a letter, whether it's a car, I need to know how to get to your house, right? And then from your firewall, you gave me instructions, or the rules of your house is, hey, any package, right? Anything that you want to give to me, right? Communicate with me, do not go through the door, the door to the side, right? Which has the number 10. Only go through the door, the front door. So the door that has the number 22, right? So that's your rule, right? And I have to respect your rules. Matter of fact, I cannot just disrespect your rule, right? The people that will disrespect your rules in this case will be called hackers, right? And that's why you need to have better security. So here's your address, a way to locate your house. Now, there's a way to do the same thing for a server, for a machine. You can locate a server in a network by looking into their IP address, something we call IP address, okay? Very, very important networking concept here. Very, very important. IP address. Okay. Well, I'm not sure why it has this thing here. Let me remove it real quick. Okay, perfect. All right. So the IP address is simply a way to locate um, a machine in in a network. Okay. So in this case, let's just say the IP address is actually, this is how every IP address look like. At least the what we call IPv4, because there are two types of IP address as of now. What we call IPv4 and IPv6. We're just gonna focus on IPv4 for now, but an IP address is basically a set of numbers, four numbers separated by a dot. So for example, an IP address will look like this: 192.20.15.23. I just made it up, okay? So what that means is when someone comes into your house and they connect to your Wi-Fi, if you're using AT&T, then you're probably familiar with the AT&T app. It's called My AT&T. No, I think it's like Home AT&T, something like that. And basically, it's an app that your AT&T provider gives you that allows you to block people from connecting to your Wi-Fi, changing your Wi-Fi passwords, a bunch of other stuff, right? So if you go using that application on your phone, you will most likely see the people that are connected to your network, right? And if you check the IP address of those phones, those computers, whatever machines are connected to your to your Wi-Fi, they will all have an IP address. Okay, and later on, I'm gonna show you how to check the IP address of a device. You can check the IP address of your iPhone if you want to. Okay, and if you have two, let's say you have two computers, right? A MacBook and a Windows, right? When you check both of their IP address, the way you can tell they're part of the same network, meaning they're connected to the same router, or they're just part of the same network. Let me not confuse you, is by looking at the similarities in their IP address. For example, the second device in your house will have something like this: 192.20.15. Actually, let me not put 15. 14.65. Okay, so here you can see there's obviously similarities, right? You can clearly tell that the first two numbers are similar, right? So this is one way to know that they are part of the same network. Okay, and the part, or the sets of numbers that are similar, that haven't changed, are what we call the network, meaning this is representing the network and this will be representing the host itself. Okay, And besides IP addresses, there's another way to locate a machine. Now, I didn't really want to talk about this other ways here because, I mean, it is a networking thing, but it won't help you to locate something that's part of a network, and you're gonna understand what I mean by now. So another identification other than the IP address of a machine is what we call the MAC address. Okay. Now the thing about the MAC address is that the MAC address is not related to your network. Meaning what? Every single machine has a MAC address. Okay. So what that means is when you disconnect your iPhone or your computer from the Wi-Fi, if you check the IP address, it's not gonna show because you're not part of a network at that point. You're off. Okay, you're not accessing any network, so the router is not gonna assign a an IP address to your device. But what you will always see is a MAC address. Okay, so the MAC address is more so for other devices, to be honest. Okay, and we can talk more about that later on. But so far, like I say, we talked about ports, we talked about firewalls that sets the rules for what traffic can go through which ports, right? And then we talked about IP address, which is the identification that your device has on network. Okay, and we can dive into stuff like subnets and so on, um, because those are also very important. So there's a term that you will hear quite often called subnet. And subnet can be quite confusing. A lot of people get very confused about subnets. I got very confused about subnets as well. So the best way to know what a subnet is, before I even talk about the actual word itself, is to go back into IP addresses. Okay, so let me add another device here. Right, let me do this right here. Okay, so you have three devices, right, that are part of the same network, right? So let's say these three machines are three computers that are connected to your Wi-Fi. Okay, now if I do this as a 16, 16, and 16. So this right here is a subnet, or this is the way to mention the subnet. And again, the way to fully understand this is I have to get a little deeper into IP addresses themselves. So, like I say, an IP address has four. Let me get back here. Okay, has four numbers. Okay, and we don't just call them numbers. These are what we call octet. Okay, octet, and it spells like this. Octet. Okay, am I spelling it right? Octet. Hold on, let me make sure I'm spelling that right. I don't wanna. Okay, I was spelling it wrong. My apologies. Well, I spelled it right here. But anyway, octet. And each octet, right, is 8 binaries. Okay. And I will invite you to, if you don't understand what a binary is, I don't want you to, don't waste too much time on that. Unless you're trying to be a not a cloud engineer, a network administrator. If you're not trying to be a network administrator, if you're trying to be like a cloud engineer or DevOps, stuff like that, just understand it in the broad way. You don't have to get too deep into it. But each octet is made up of 8 binaries. Okay, binaries. And if you've ever been, I mean, IT driven or whatever, you've probably seen stuff like 110011. This is basically what we call binaries, and this is how computers communicate. And I don't want to confuse you too much, but let's get back to this the subject of subnets. Okay, so the reason why you see 16 here is because the first octet. Remember, look at these three IP addresses. What do you notice? You notice what? The first two numbers are not changing, right? Okay. So the subnets here is telling you that the first two what? Octet, right? Are not going to change. They are taken, if that makes sense. So that's why we have the /16 here. Remember, the number 16 here. Why is it 16? Why not 14 or 25? Well, like I said, one octet. So each of these octets are 8 binaries. And as you can see, the first two octets are taken. If one octet is 8 binaries, how many binaries is 2 octets? Obviously, it's 8 plus 8, which would be 16, right? So if I put something like this next to an IP address, the /16, what I'm saying is in this network, right, you can only have these many IP addresses. And what do I even mean by these many IP addresses? So when it comes to IP addresses, they will go from 0.0.0.0-8, right? All the way to 25, oh, not 25, 255, 255, 255, 255. And actually, I think it's 256. Let me confirm that real quick. Okay. Anyway, I was right. So, like I was saying, it's 0.0.0.0.0 all the way to all those octets going all the way up to 255. Do you understand? So what that means in the event of having a subnet that says 16, meaning the first two octets are taken. So they can't change. They will not change. What that means is in that system, you only have, so the router will assign these many IP addresses. So you have 1.2, 20.0.0 all the way to what? 1.2, 20 dot what? 255.255. And if you're still confused, a router, remember in your house when you get your Wi-Fi, why the router is the boss or the guy that provides all these IP addresses, all right? Well, I mean, it's a little deeper than that, but just to make it simpler to understand, okay? And once you have your subnet sets, or you meaning the amount of hosts you can have in your network, right? Well, subnet doesn't totally just do that, but in any way, your IP, your ISP, meaning the people that provide your internet service, right, will allow you to have a certain amount of host, right, a certain amount of machines, computers, phone, whatever, in your network. And if you want more, then you can talk to them, because the amount of machines that is expected in a regular home is obviously not the amount of machine that is expected in an office, for example, right? So obviously an office will be charged differently than a regular house, okay? That's why usually when the prices changes, when you go to like AT&T for your home, it's usually in terms of speed, right? So again, in our case, we have a subnet 16 here, right? So these first two octets are blocked, right? Not blocked, but they're taken. So in this network, It means what? You will have IP addresses that will range from this IP right here to this IP address right here. Okay. And usually the first IP address belongs to the router. Okay. And there are other, when you come to what we call the cloud, you will find out that the other IP addresses that you can't use. But anyway, that's another topic for another day. Okay. So that's basically it about subnets. And subnets are very important to understand because when you get into a network and you can't reach subnets, you won't be able to, know about, which server is part of each, which network, and so on and so on. Okay. So it's very important to understand that because the subnet here that you put here, will either reduce or increase the amount of servers that you can use within that network. Okay. Very important stuff. All right. So you heard me speak about something called routers, right? Routers, very important concept. Just think of a router, which we all have routers at home. Just think of a router as the mailman. Okay, so it gets the mail and knows how to distribute the mail. Okay, that's really all it does. It distributes traffic. Okay, remember, we're talking in terms of traffic, we're talking in terms of data here. So the router will distribute that data. Okay, and your firewall will decide where the data goes, where the data cannot go, who can send the data from where, and so on and so on. And your IP address is the way your router knows who to send the data to in that specific network. All right. So another, I guess, term or concept that you need to understand is that these numbers are not random numbers. Okay. They can be random numbers when you want them to be random. And what I'm trying to say here is when you have a server, right? Like this house right here, each server serves a purpose. So, for example, if you have an infrastructure, an IT infrastructure, meaning when someone logs into facebook.com, that page that you see is most likely the web server. And when you put in your password and your username, those information to make sure that you do have an account, those information are stored in a database server, which is a different server. Because if you do everything on one server, which you can if you want to, it just won't make any sense. And this is what we call in IT network segmentation. Okay, it just won't make any sense. So, because really, what makes a web server, besides the configuration part, is the fact that it has an application that allows web services. Okay, same thing, same understanding with database servers. All right. So in our case, let's say this house or this server is a web server. Okay. So in order for it to be a web server, you will have to install what we call a web service or web server application, right? One of the most famous one is something that we call Apache, right? And that's the name of the company, if I'm not mistaken. But the actual application is really called HTTPD. Okay. And sometimes you will notice when you go on websites, you will see HTTP, and sometimes you will see HTTPS, and that S really stands for secure. Okay. So, for example, in the case of this house, of this server, if we have web traffic, okay, so web traffic by default, HTTPD, HTTP D, sorry, I'm trying my best to, you know, the traffic when you install it by default configuration, the traffic will go through port 80, okay, on your server, port 80. So it's gonna go to through this window here. All right. So back and forth traffic when you install, it goes through 80 by default. All right. So this computer here is trying to access that. Okay. It's gonna go there by default. Now, remember, your firewall can decide to stop the traffic. Who can listen to the traffic? Okay. And also, you can change this configuration. You can set the port number for HTTPD to go through whatever port number you want. I believe you have access to 0 or 1 to 6006 something. You can look that up. And that's a great way to also do some security stuff, all right? Because if everybody knows which port the traffic is going through, then if someone has malicious intent, they will know exactly where to sit, so they can also uh, listen into the communication go through that door. Okay, so another thing you need to understand is, for example, 443 also stands for a specific configuration port, and this time it stands for HTTPS. Okay, so that the secure, but we can talk about that much later on. And then same thing, 22, it's not just a random number. It stands for SSH. Okay, and SSH is just the secure way you can log into a server. All right, and that too, you can change that. You can log into the server, and you can make sure that the connection doesn't go through 22 anymore. Okay. All right. So I'm trying to make sure that this video is not too long, but these are pretty much not all the fundamentals. There are other things that we need to talk about, like the OSI model, which is basically the understanding of how traffic flows from one computer to another computer, right? We will talk about the OSI model. You go from you go from application, I believe it's session or presentation, and then session, transport, and then network, and data link, if I'm not mistaken. I'm a little rusty when it comes to OSI model talk. I haven't looked into that in a while, but there you go. So I need you to watch this video, and if you have any questions, you know where to reach out, how to reach out to me, and or put comment in the comment section, and I will make sure to answer your question. All right. Thank you very much for watching this video. Stay pseudo, my friend.